Hi, this is Karen, and in this video we explain the basics of the p-value. Here's the first thing you need to know. At the end of the day, statistics aren't based on exact truths. They're based on estimates. Think for a minute about the estimation game you might have played as a kid, where you had to guess the number of objects, in this case green peas, in a jar. As a sophisticated kiddo, you might have come up with your estimate by counting the number of peas across the bottom, multiplying that number by itself to try to account for the depth of the jar, and then multiplying that number by the number of peas you counted up one of the sides. And voila, you have your estimate. Even as a kid, you probably used certain properties of the peas, your data, to come up with your estimate. Statistical packages do the same thing. They use the properties of the numbers in your data set to make an estimate. And because it's an estimate, we can't say that our results are 100% correct. We have to acknowledge that there might be some other reason out in the big wide world that made the results come out the way that they did. What that really means is that the results could have happened by chance, or they're due to something that we didn't measure. The possibility that that's what happened is what's represented in the p-value. If you think about decision making based on your data, the p-value is sort of like your risk factor. It's the probability that your results happened by chance. And so naturally, we want that possibility to be as low as possible if we're going to use our data to make decisions. In education and social sciences, p less than 0.05 is the conventional cutoff. Other disciplines have more stringent cutoffs, but for our purposes, anything less than 0.05 is considered good enough. But what does that really mean? If you got a p-value of less than 0.05, then that means that there's a 5% chance that your results are based on something other than what you measured. Another way to think about it is that the risk you take in making a decision based on your data is 5%. Similarly, p less than 0.01 means that the probability of your results being based on chance or on something that you didn't measure is 1%, and so you have a risk level of 1%. And p less than 0.001 means that the probability that your results are based on chance or something that you didn't measure is less than 0.1%. All statistics make comparisons, either among groups within your data or between one value in your data and another known value. Your evaluation questions help you figure out which group differences matter to you. A significant p-value means that there actually are differences between your groups. For example, in the chi-square conceptual video, we use tween versus teen audiences and a yes-no variable about whether kids want to attend a similar event in the future. The chi-square test assumes that tweens and teens will want to attend a future event at similar rates. A p-value of less than 0.05 means that tweens and teens report different rates from one another. The same assumptions are also made for the t-test and the ANOVA. In the t-test how-to video, we use the example of event ratings and binary gender. Here again, the t-test assumes that binary boys and binary girls will rate the event similarly. If you get a p-value of less than 0.05, then that tells us that these two groups are actually rating the event differently. For the statistical tests in this video series, the smaller the p-value, the more confident you can be in your results, because smaller p-values are telling you that there is less and less of a possibility that your results happened by chance or due to something that you didn't measure. The better your data, the better your estimates. Each statistical analysis is based on a number of rules or assumptions about your data. In almost all cases, the larger the sample, the better your estimates will be, because you have data on a larger portion of the entire population that you're trying to study. Having confidence in the estimates provided by the data is particularly important for evaluation, because we hope and expect that programming decisions will be made based on our results. Whether a statistically significant result has practical implications for your program is up to you. We hope this video has helped provide a basic understanding of p-value and what it means in relation to statistical analyses. The specific kinds of estimates that the p-value reflects will be covered in each of the subsequent videos in this series. For now, this is Karen signing off. Have fun and good luck.